In this part, I will talk about black box test design, various black box test design techniques, and how Conformiq automated test design is related to all this. Black box test design is an activity where a test engineer, based on various sources of information such as the requirement specification, functional specification, maybe user documentation and expert opinion, decides what kind of test cases are needed to test a system. The goal of black box test design and black box testing is to verify that the system under test works as specified. In creating black box tests, a test designer uses various test design heuristics, some of which are listed here. In equivalence class partitioning, the test designer looks at different conditions in the system, different executions of the system, and then based on that tries to classify these different executions to equivalent functionality, and thus minimizing the test work, yet trying to test the system as well as possible. A bit more fine-grained test design heuristic is boundary value analysis, where you look at the different boundaries of the conditions and then based on that generate test cases that exercise the system on the different sides of these boundaries. And the reason this is an important test design heuristic is that off-by-one errors around such boundaries are a very common programming error. In decision table testing, one combines different conditions with each other, creating kind of combinatorial testing. Let's say that you have two variables with each distinct with 5 distinct values each. So then you could create a decision table and just tabulate all the possible combinations of these values to get 25 test cases to test a system. Then there are other test design heuristics that can be used, but in the end the idea is that the engineer needs to choose the optimal one for a particular system to come up with a good set of test cases to test the system. Now, this manual test design is a demanding task and therefore involves risk. The test designer can miss test cases, create incorrect test cases, and redundant test cases. And then as a result, the defects escape to the field. The test designer needs to do rework because the test cases weren't correct. And over time you end up doing a lot of non-productive work because you copy-paste the test cases as the system evolves. You copy-paste test case B from test case A because it's almost the same. And then in the end you just end up having a huge maintenance burden throughout the testing of a product. And automated test design and Conformiq Designer is all about significant reductions in these risks in the manual test design process. When one talks about black box test automation, it's important to understand that there are two distinct phases in the process flow of testing. Traditionally, when one talks about test automation, one refers to test execution. You use different programming languages and scripting languages, and then you manually write test cases and scripts that execute on this test execution engine and exercise in the end the system under test. And when you use Conformiq Designer and automated test design, this test execution automation, it remains the same. The difference is that in automated test design, also this test design activity here on the top of the stack is automated. So you have Conformiq Designer, which takes a system model and then feeds the test execution subsystem with automatically generated test cases and concrete test scripts. So if you already have invested in automating your test execution, this investment can still be used when you introduce automated test design. It just sits on top of the existing test execution automation system. This slide then describes how Conformiq automated test design works. So the way you see your system under test, or your real system, is that it's a black box here with a number of distinct interfaces, and then the system interacts with its environment through these interfaces. These interfaces, they can be the user interface, or they can be an API, or the protocol, message-based protocol interface towards another protocol entity. Regardless of what kind of system you are testing and modeling, what you do in automated test design for Conformiq Designer is that you create a model of the system under test, and this model you should see as an abstract implementation of the real system. That's why it basically has here the same shape and form as the real system, and it has the same kind of interfaces as the real system. And then in the model, with respect to these external interfaces of the system under test, you describe the functionalities of the system. You take the specification and you rewrite it in a language that Conformiq Designer understands. And then Conformiq Designer takes the model and synthesizes a tester around the real system. So it does exactly the same thing as a human would do, given the same human readable specification. It generates test cases which first send something into this interface of the real system, then they expect something out of this interface, then put something into this interface, and so on. But here the point is that given the specification as a model, Conformiq Designer will exhaustively look at all the interesting behaviors with respect to those test design heuristics that the tester design asks Conformiq Designer to use, and will guarantee that you get a test case that covers all the corner cases, boundary value conditions, etc. of the real system. And that is the key of the automated test design, if you compare that to the manual way of doing things.